You can find me at tlentini on GitHub or Twitter. I'm not super active, but trying to get more active there. So why this session? Well, let me answer that by telling a little bit of a story. So a few years back, we decided to embark upon a rewrite of our software. It was a traditional client-server app installed on-prem on our client's site. Basically rewrote the software, tested it, packaged it up, helped them install it and configure it, and then we kind of wiped our hands of it, right? It's up to them to maintain the uptime and keep it backups and everything else going. And what we wanted to do was basically embrace the cloud. So we wanted to start from the ground up, cloud native, essentially, application. And in the process, fix things that we got wrong with the initial design of the application. So as we started going down this path, we started looking at our clients. And we have a lot of small clients that basically their usage of the application is maybe a handful of times a month, maybe even a quarter, because it's a client compliance tool. So they kind of open it up, do their stuff, run their reports, and then close it down, and they never open it up again. And then on the other end of the spectrum, we have some really large institutional accounts that have many users in the application. They still have that same spiky kind of traffic at the end of the month or start of a quarter. But they also have users that are in there pretty much routinely every day running reports and doing analysis of data. So we kind of have this this dichotomy that we had to sort of balance out. So this talk, in part, is some lessons learned that we kind of went through with this process of kind of trying to figure out how to embrace the cloud and with our application. So kind of a few constraints, just kind of lay out the rest of the story here. What we're talking about is relational data. NoSQL really isn't a great fit for the type of data that we work with. We're primarily a Microsoft shop, love Microsoft tools. Very familiar with SQL Server, although we don't have DBAs on staff. Most of our developers are really competent with SQL, embrace it, to the point where we kind of shy away from ORMs and things like that. And what we knew we wanted to be able to do was keep client data siloed as we needed to. But we also wanted the ability to scale up and scale out to meet kind of this interesting peak demand usage that we saw with our clients. And ideally, to cap it all off, we didn't want to manage things like backups, availability, things like that. Like I said, we don't have a DBA on staff. I want somebody else to do this, ideally. So that's kind of what we were working with. So that said, what are our options? Well, let's start with the database side of it first, right? We could put SQL Server in a VM, or we could embrace Azure SQL Database, kind of one option. From the database design perspective, historically, all of our schema had been really single tenant. But we had the chance to start over. So we said, well, we can either embrace single tenant, which is one customer per database, or multi-tenant, which is multiple customers in the same database. So you kind of have this option there. And then as far as the application layer communicating with the backend database, we could either roll our own solution to try to figure out how to route the connections, or we could try to find something off the shelf. So let me talk a minute about SQL Server, kind of some of the options available to us. If you put SQL Server in a VM, whether it's on-prem or in the cloud, that's infrastructure as a service. You own it. You got to patch the hardware, patch the operating system. You got to take care of the backups, things of that nature. I didn't want to deal with that. So SQL Server in a VM was out of the picture for us. So that led us to basically Azure SQL Database. And if you're not familiar with it, there's kind of two price points. A DTU-based pricing model, where a DTU stands for a database throughput unit. And it's a blended measure of CPU, memory, and IOPS, essentially. And nobody knows what the hell this is. I've been working with this forever. I still can't understand what a DTU is. It's highly scalable. It's customizable. You can have a little slider in the portal, and you can go from an S2 to an S3. And that basically means you go from 50 DTUs to 100 DTUs. So you kind of like double your throughput. But in terms of comparison of saying, like, how much gigs of RAM am I getting here, there's no sort of matrix there for you to figure out. So that was one of the big complaints that people had. Unfortunately, Microsoft listened, and they announced a vCore pricing model, where depending upon the hardware, one vCore is either equal to one hyperthread in the Gen 5 hardware, or in the Gen 4, the previous version, one vCore was one CPU. So it's a much more traditional, transparent approach to the pricing. You kind of know exactly how many gigs of RAM you're getting, you know kind of what the CPU processing speed is going to be. I enjoy this. This makes more sense to me. Yep.
Can you switch between them?
You can, yeah. You can swap between those two different things. As far as the size of your database and log files, things like that, both of them you can configure. So you can say, I want to go up to a terabyte of disk space. If you need to, you can do it. And again, that's a slider in configuration. You can configure the log files as well. Both of these options, DTU and vCore, you can either provision as a single standalone database, in which case you're billed per that database, whatever tier you've selected. Or you can use something called an elastic pool. An elastic pool allows you to put multiple databases in the same sort of pool, and you're billed for that pool's usage. So I like to think about this as basically I'm leasing some compute resources, maybe on a server someplace, and I shove a bunch of databases there. They all share that CPU and that RAM. So if one database gets hammered, the other ones might suffer, but I'm able to basically be billed for that one unit of measure. So it's kind of great for situations where you have some spiky traffic or some clients that don't use it very often, and maybe other ones that are a little bit more usage. You can kind of blend this and spread this out. And the latest offering that they've announced recently is Managed Instance. Again, it's relatively new. It's bridging the gap between infrastructure as a service, SQL Server on a VM, and this platform as a service. It's kind of going right in between there. You get a few things that you don't necessarily get with the standard sort of DTU or vCore pricing. Unfortunately, this wasn't available when we started this process, so this is the extent of my knowledge about that. It's there if you need it, so you can find out more information. So with the database set, we basically said, all right, we're either going to do DTU or switch to vCore pricing. So the next question became, how are we going to manage this application layer? If we're going to have SQL Server Database, how are we going to figure out how to put all of our client data there and how we're going to route traffic? So Elastic Database Tools is kind of the answer. So Elastic Database Tools is a suite of offerings from Microsoft. And it's broken up into these different categories. We'll touch on all of these. We're not going to go into depth on everything because we'd be here all night. Elastic Database Client Library is really the guts of what we'll look at. And this is kind of where most of the magic happens. So this is a client-side library that you're going to consume in your application, either NuGet or they have a Java version as well. And this enables you to maintain your sharded databases, your shard map managers, and to route your connections from your application into the database. Yep.
So it has nothing to do with Elasticsearch or Elastic Database?
Yeah, it's unfortunately, Elastic is a common name, I guess, with that. So Elastic Database Split Merge Tool is a service that you can use that allows you to physically move data from one database to another. So if you have multiple databases with customer data and you say, hey, customer 2 needs to go into this other database, this service will let you physically move that data and take that tenant offline and push the data to a different database for you. Elastic Database Jobs, think of this as like SQL Server Agent. So with Azure SQL Database, you don't get SQL Server Agent. This is the closest thing to that, or if you're going to run your routine reindexing and updating statistics, those types of tasks, anything that you're going to run in the database, that's where you're going to do this, is through the database jobs.
Can you use these Elastic tools with any of the options available in the previous slide? If you choose something previous,
yeah.
does that limit you to not?
No, these are all kind of independent. That's a great question. These are all independent, really, of SQL Server, whichever version you choose there, which is cool. The Elastic Database Query is basically, it's still in preview, but it's a technique or a tool that allows you to run T-SQL statements that span multiple databases. So let's say I have 5 databases that have different customer information, and I want to aggregate all that together for some sort of use case or metrics or reporting. I can issue a query that will span all of those and bring all the results back to me in one sort of pull. So at this point, I want to take a couple slides to define a couple terms, because I want to make sure that the terms I'm using are you're understanding what I'm saying, because there's a lot of confusion about this, and it's taken me a long time to nail the vernacular. So sharding is basically a technique to distribute large amounts of identically structured data across a number of independent databases. So the example I like to think about is if I have a traditional SaaS application where I've got multiple customers in there. Sharding is a technique that I can basically take that customer data and push each customer into their own database if I want to, but be able to, from the application layer, route my connections to the correct database when I need to return customer 5's data, for example. So sharding allows us to really kind of scale our data and across multiple machines even if we need to, if we have a large volume of information. So a couple of key terms. A shard is basically a database, but it just is a database that happens to be in something called a shard set. A shard set is the group of databases or shards that are managed by the same shard map manager. A sharding key is the column value that determines basically how data is distributed across shards. So you might think about something like a customer ID as being a natural sharding key. A shard map and a shard map manager kind of work together, but it's basically a specialized database that contains metadata about what data resides in each shard. So I can say, for example, customers 1, 2, and 3 are in database 1, 4, 5, and 6 are in database 2. The shard map and shard map manager database basically manage all of that information, that metadata, so that my application can route the requests as needed. And a shardlet is all the data that's associated with a single sharding key. So if you think about that customer data again, all of the data that resides or that pertains to customer 2, that's considered the shardlet. So that's the smallest unit of measure. If you use the split merge tool, that's what's going to it's going to go out and basically find all of the data, all the transactions related to customer 2, and merge them out or split them out to a different database. And I really like this this graphic from Microsoft because I think it does a better job than just the definitions do. At the top, you kind of see the shard map manager. It's a specialized database, and it basically contains information about the shards or my shard set below it. So here we've got 3 different databases that are shards, and inside of each database are multiple customers. So on the bottom we've got customers 0 to 100, 100 to 200, 200 to 300, et cetera. On the left, they kind of blew out this definition of what a shard is, and you can see the sharding key is the customer ID, and then in this particular shard, customers 1, 2, and 3 are considered shardlets of the data. And then for good measure, just to confuse things, they have a reference table here that's down in the bottom. So we'll talk a little bit about reference data in a second. A couple of final terms here. A tenant is basically, you can think of as the end customer. Single tenant model is one customer per database, whereas a multi-tenant model is multiple customers in the same database. Data-dependent routing is a functionality that enables your application to route a request and connect to a given shard given a specific sharding key. So for my application, and if I have a request for customer 10, I want to make sure that my connection goes to the right database to retrieve customer 10's data, wherever that may be. And a multi-shard query is the ability to issue a query that spans multiple databases to return all the results. So if I want to get a list of all my customers and they're spread out across 10 different databases, I would create a multi-shard query that would go out and basically connect to each one of those databases, issue my statement, aggregate their information back to me via a union all statement, and so then I have all the data. It's very similar to Elastic Query. It just this happens within your application via the client library. Yep.
Is this like, I don't know what the compliancy would be, but for segregation of data, compliant with certain,
Yeah.
there has to be some compliance that says if you do this, you're compliant, and no data shall touch another person.
You can manage that yourself. I don't know that this necessarily guarantees that because we'll see a couple examples in the demos of things that can go bad. So it's a great question. You have to be careful with it for sure.
And are you going to talk about keys in a little bit?
Yep, absolutely. Right here, actually. So sharding key, we talked about this slide or two ago. Great question. It's basically the column value that determines how data is distributed across the shards. So again, we're going to think about a customer ID as a classic example. There's a few different supported types that you can use for your sharding key. So integer, long, GUID, byte array, date time, some time span offsets, et cetera. I think in practice, you'll find probably integer, long, and GUID are the most common identifiers there. I think the date time components probably are useful if you're ingesting a lot of temporal time data. And you basically want to say, I want to ingest all the data for this month, and then new month starts, and I'm going to start ingesting data for that month into a different database. That's kind of what they were thinking with that. We got a couple more slides about definitions here, but then we'll be done with this. We talked a little bit about the sharding maps. This is basically just the mapping between sharding keys and their respective shards. And it's basically, you can think about it as a specialized database that just keeps track of which customers are in which database. There's 2 types of shard maps that you can create, and which one you use depends upon your database schema. So there's a list shard map, which basically says 1, 5, 2, 3, 4, et cetera, in a different database. Or you can do a range, 1 to 100, 100 to 200, et cetera. If you're using a single tenant model where one customer per database, you're going to use a list mapping. That's the best choice for you. If you're doing a multi-tenant database model, you have your choice, list mapping or range mapping. It's really up to you what you want to use. I'm not certain that there's any real benefit over one versus the other necessarily. And this is just a quick slide of some diagrams here. So upper left-hand quadrant, we've got a multi-tenant database model where we're using a range. So we've got tenant 1 through 5, 6 through 15, 20 to 25 in different databases. Upper right is using a multi-tenant just with a list mapping. And the bottom is a single tenant model where we're using a list mapping there as well, 1 tenant per database. All right, so anyone confused?
Is there any performance hit with doing this?
Yeah. Yeah, it depends. We'll talk about that in a minute. We'll come back to it. All right.
Do I need to modify my application to work with this, or is it handled transparently on the back end when I say?
You will need a little bit of modification, and we'll see that how basically these client libraries can be implemented within your application to control that data access layer and how we're communicating. So how do you get started with all this? Because we've covered a lot of information already, but I would say the biggest question you have to ask yourself, is this greenfield development or brownfield? Are you creating something from scratch, or are you leveraging an existing application? I'd argue that if you're doing brownfield development, say you have a classic sort of single tenant app and you want to put it up in the cloud and you want to make it a multi-tenant application of some sort, chances are the best fit for you is going to be to adopt a single tenant per database model. And I say that because you're probably not going to want to go in through your database and add the sharding key to every single table to make sure that everything is unique, and that if you needed to go through a split merge, that you could perform that. So it's much easier to just basically say each customer gets their own database. Greenfield, the sky's the limit. You can do whatever you want. So you might have a chance to look at your situation and say, well, it might make sense for some clients to be in their own database, but others we might want to try to pack them together, and you can kind of mix and match a little bit as you need to. This is related, I guess, to basically understanding your usage of your application. Do you have sporadic traffic through your app for given clients, or is it really consistent? And that's going to decide or help you determine whether or not you're going to use Elastic Pools for your database, or whether you're going to use standalone databases. If you have a client that you know is always beating on the system, you're probably going to put them in their own database outside of a pool or in their own pool, and just treat them with kid gloves, where all your other clients maybe are able to be in an Elastic Pool together. And again, are you going to choose a single database tenant model or multi-tenant model here? I will say it's very tempting to say every customer gets their own database, right? But you better have a really good database DevOps strategy if you're going to do that, because if you're managing hundreds of databases, how are you going to put schema changes out there, et cetera? So devil's in the details with all this stuff, certainly. So just be aware that that's one drawback. There's a lot of benefits to having every customer in their own database as well. Your customer might decide, hey, I want to have a backup of my database or my data, and you can easily just give them the backpack file, for example, and they can put it on their own system. It's harder to do that if you have multiple tenants in the same database, right? Restores become very tricky as well. If you have a multi-tenant model, chances are you're not going to restore a database if somebody screws something up. Your application is going to have to recover for that. So you might have to implement some sort of recycle bin, for example, of deleted data, or have some way of restoring it, customers' individualized data, as opposed to just falling back to the database backup.
Can't you just give the customer the backup to restore and then say, just ignore these other?
Yeah, exactly. It goes with the compliance tools, I guess, right? And I guess the other question is really, do you have any regulatory or other data privacy concerns as well? I know for us, we have some clients that are absolutely say, my data can't be with any other database, or any other customer's data has to be in his own database. We have others that don't care as much. All right, so I'm going to get on a soapbox here a little bit and give you a couple of opinions.
You may have said this
Yep.
already, but if you're do you have to put a sharding key in as a column in each table? Or?
If you do a multi-tenant database, you should. Yeah, absolutely. Yep.
Shard a multi-tenant database across shard the individual tables themselves.
Shard the individual tables themselves. Ooh. I don't know about that one. That would be interesting. Let me think about that. All right, so first things first, be careful the sharding key type that you use, all right? A lot of us are going to say, geez, GUID, that's a great fit, right? I can develop that inside of my application. I can send it in. I don't have to query the system to get the new key back, et cetera. Well, in a multi-tenant database, that might not be a good idea, all right? Example, GUIDs, we all know, lead to index fragmentation within your databases. And it's also going to bloat your database. If every single table has your tenant identifier in it, and you're using a GUID, you're artificially inflating your database as opposed to using an int or a big int, right? 16 bytes versus 4 for an int, for example. So depending on the size of your database and the data that you're working with, this might not be a big deal. If you have millions of records, it could add up pretty quickly, especially if you also factor in the size of the keys and the indexes that are incorporating that clustered index in the primary key. Put reference and lookup data tables into a different schema. Don't use DBO for this. So for example, if you have zip codes or states or tax codes or things like that that are universal across all of your customers, put that into a separate table, obviously, but put it into a different schema. it'll make your life easier down the road. And I'll talk about why in a second. This has nothing to do with scalable cloud databases, it just has to do with good database practice. Please be consistent. Use either plural or singular table names. Don't mix and match. Be particular about the field names that you're providing, and especially primary key fields. And this is where I'm really opinionated. My view is that primary key fields should be easily recognizable, not only to the table, the parent table that they belong to, but also the data type that you're using. For example, if you have a customer table and you say ID is the primary key, that's horrible, because when you reference that field in the order table, you're going to have to alias that field and say it's customer ID. So now the customer ID joins the ID of the customer table, and that's just, who can keep track of that as your database schema goes up. Customer ID is better, all right? It tells me what table this relates to, but I have no idea what the data type of this thing is. Is it an int? Is it a big int? Is it a GUID? I have no idea. I prefer something like IX customer, and this is a little bit like Hungarian notation. So I for integer, X tells me it's a clustered, or the primary key clustered index, and customer tells me the parent table. If it's a big int, it becomes BX customer. If it's a GUID, it becomes GX customer. This way I know as I'm joining things around and I know I'm looking at the data what it is. Again, I'm a database guy. This is my preference. I don't use Entity Framework very frequently, so I'm much more comfortable joining things and writing my own SQL. It just helps me know what I'm dealing with that. So get off my soapbox for now. So the Elastic Database Client Libraries. I mentioned a little bit earlier that this is available for both .NET and Java. And if you go out to NuGet, you're going to pull in the Microsoft Azure SQL Database Elastic Scale Client, which is a mouthful. What this library allows your application to do is manage your shard map manager database and the different shards that you're going to add. It's going to enable or facilitate data-dependent routing, which is the technique that allows us to say, give me customer 5's data, and it just basically magically routes that connection to the appropriate database. It allows multi-shard querying, and it allows for adding additional shards over time. So if you add a new database, you can basically register that with the shard map manager database, and all of a sudden it's available for use. If you go out and Google Elastic Database Tools for .NET, you're going to come to this page. And it's got a pretty good sample you can download. It's going to pull in the NuGet package for you and basically let you see the source code of what you're going to connect to and run. We're not going to use this tonight, but I encourage everyone to go out and check this out. It's a reasonably efficient demo that kind of gives you a good idea of what to expect. Let's talk about kind of configuration, how you use this. And we'll see some demos of this, but I want to set the stage a little bit. So the first step is assuming that you have databases already, a customer database for your schema. The first thing you're going to do is create a new shard map manager database. You're just going to create an empty database. And you're going to create an instance of a shard map manager instance, which is going to allow you to register this database. And what that basically does is it adds some tables and store procedures to this shard map manager database that basically allows you to keep track of, or allows the system to keep track of, what are all the databases part of my shard set, what customers map to which one. Once I set up this manager database, I can then go ahead and register each shard or each database with it. And again, I'm going to tell it, hey, I'm using a range mapping or a list mapping, and these are the ranges of customers that belong here. And then optionally, you can also run a process to basically apply schema collection info or schema info collection details to that shard map manager database. This is really important if you think you're going to need to split and merge your data over time. Basically, what you need to tell the system is these are all the data, or these are all the tables that contain sharded data that need to be potentially moved to a different database. And these are all my tables that are reference or lookup data. And it won't move that because it's assuming that you have managed all the reference data across all these different tables. So how often do zip codes change, or area codes, things like that? You're responsible for managing that identical data across all of your shards. That's why I think it's important to segregate the tenant data from the reference data in your schema, because it's really easy to then query and say, give me all the tables that are part of my ref schema and register them as reference tables, and give me everything as part of DBO, and that automatically is all of my sharded data. Just a tip from me. A couple of other tips. Keep the shard map management aspect out of your main application. You might have a compelling reason not to do this, but I would favor a dedicated management app I don't think there's really any reason that your users are going to need to be registering new databases and things like that via your application. The demo apps from Microsoft don't do this. They kind of bundle these things together. And I'd really like them to create a reference app that didn't do this, but maybe I'll have to build it or something. And I think you should be a little wary of code-first migrations when you're using this, if you're using Entity Framework. My only rationale for that is I think if you're at the stage where you're developing multi-tenant applications and databases, you probably want your database under source control. You probably want to have a better strategy for distributing changes across your different shards over time. So Entity Framework code-first migrations are great for smaller apps and getting jump-started, but I think for something like this, if you're building something of scale, I'd be wary of using that. Again, my personal preference. Let's see, couple more slides and we'll see some demos. So after we have the Shard Map Manager database, our application needs to be able to connect to the correct shard to return the customer data. This is done by something called data-dependent routing. And at the same time, there's also situations where you might want to issue a multi-shard query, and that can also be handled via this library. And this is the part of your application that starts to change a little bit. So I don't know if this is convenient or not, but you have a Shard Map Manager database, and then there's a Shard Map Manager instance. And kind of, in my mind, I get them a little confused initially. So the Shard Map Manager instance is basically what enables you to create the Shard Map Manager database and all that, register everything. But from your application, it also contains methods to enable these connections to be routed to the appropriate place. So the guidance from Microsoft is basically, in your application startup, initialize one of these Shard Map Manager instances and keep it around. This is a singleton. Keep it around your application. As it initializes, it's going to go out and query your Shard Map Manager database and get a listing of all the databases that are part of your shard set, which customers belong in each database, and it's going to cache that in memory for you. Every future request that your application makes, be it Entity Framework or ADO.NET, you're going to basically use this Shard Map Manager instance that you have in memory and say, hey, I need a connection for customer 2. It's going to look up in its map in memory and say, customer 2 is database 3. Here's an open connection to database 3. Go have at it. And at that point, EF or ADO.NET, it's just an open connection that you can work with for that request. And you can configure the Shard Map Manager instance to basically periodically either refresh itself. So for example, if it doesn't, if you've added a new shard and it doesn't have that, it can go out and query the Shard Map Manager database, refresh its cache, etc. So that's basically why Microsoft wants you to keep one instance of this around per app domain. They don't want you to necessarily close this and restart it up, because if you're doing that, then every request that your application makes first goes to the Shard Map Manager database to instantiate this object, and then it routes the request to the database. So that's the performance hit that you could potentially take if you're doing this incorrectly. Anyone use Entity Framework a lot? All right, I figured. So the examples that Microsoft provides for this is basically creating a special elastic scale context, and it essentially wraps your DB context. And in the constructor for this elastic scale context, you basically provide an instance of the shard map from your Shard Map Manager. You provide the sharding key, so what customer do you want to request, are you requesting data for? And then the connection string to the Shard Map Manager database, and that's just in case it needs to go out and query for that. Inside of this, the example methods that they give you is they're going to call the open connection for key. So they're going to basically say, I've got tenant 5, open a connection for this. And this thing will go out and instantiate a database connection, return that back to you, and you pass that into your DB context constructor, basically, the base class. And all of a sudden, Entity Framework is now ready to query that particular database for you. And the next request comes in, you do it, pass in a different tenant key. Yep. They added that recently this year, I think, or late last year for FreeF Core. So ADO.NET is very similar. If you do classic ADO or ADO.NET, you're basically going to either get a range map or a list map from your Shard Map Manager. That's just dependent upon how you configure things in the first place. You're going to run or use the open connection for key method, providing, again, the sharding key and the connection string to the database. And again, it's the Shard Map Manager database. You don't know any of the other databases that are out there. You just care about what's my connection string to the Shard Map Manager. And you're going to get an open SQL connection that you can then use throughout your application for your request. So if you want to issue a database reader or a data set or anything like that, It just looks like an open connection to you, which is pretty cool. Entity framework and multi-shard queries. Yep.
You just need the connection to the shard manager.
Yeah.
And it has the other connection strings in there.
Yeah, exactly. So that's a great point. The user that you are connecting to that shard map manager database also needs to have permission, read and potentially write permission probably to those other databases. So you might be using in SQL Azure Database a contained database user account, for example. That same database user is going to be across all of those different sharded databases so that you can do the connections. The reading of that doesn't require any elevated permissions, but the creating and managing of those shard maps, that does require elevated permission within the database, which is why I think you should take the management aspect of all the shards and put it into a separate management app. So unfortunately, multi-shard queries are not supported in any framework. But it's open source, so if you really need it, go build it and issue a pull request. Fortunately, they are available within ADO.NET. And to do these, basically what you're going to do is create something called a multi-shard connection object. And you basically provide just the connection string to the shard map manager database, and you give it basically an IEnumerable of the shards that you're working with. And this is going to give you back a multi-shard connection object. And from there, you can say, it's basically a normal SQL connection at that point. You say, hey, here's my command, go query, give me a list of all of the customers that are in the system or all the users that are part of my system, et cetera. And it will return those. And you can, interestingly, control whether or not you get partial or full results back from this and what happens. So if all of the queries fail in this fan out, or one of the queries fails, you can say, right, it's good enough with the results I have, or you can say, no, I need results from every single connection from the database in order to proceed. All right, any questions before we get into the demo? No? All right.
So the IEnumerable charts, you just list what charts you want for a subset.
Yeah, yeah, exactly. In most cases, I think you're probably going to query across all shards. So you basically say, my shard map, just get all shards and just pass that in from that method. We'll kind of take a look at that. But yeah, all right, so give me a second here to figure out how to bring this up. Ugh. Okay, so I didn't want to just take the delete these things. I didn't want to take the basic examples that you can get from Microsoft. I wanted to modify a few of them just to give you a little bit better vision here of what this all looks like. So what I've done right now is I've got a, this is horrible. Try to zoom in on this. I've got an empty database here, a blog shard manager database. Nothing special about this. It just happens to be this container that this is where my shard manager information is going to go to. In my solution over here, I've got a couple of different items. I have the shard map manager database, which is really just an empty placeholder here for the data. I've already published this. And then I've got the entity framework blogging database, essentially. So I've got blogs, I've got posts, and I've got users here. What I'm going to do is go ahead and publish this database twice to my SQL Server instance. And you notice I'm running this all locally. That's the cool thing about Elastic Scale is you can run it locally because it has nothing to do with Azure SQL Database by default. To get obviously all the benefits of scaling and infinite scale, essentially, you're going to want to put your databases in Azure. But so let me go ahead and publish this to a database called blogshard1, and completes. Let's do this again. Okay, so nothing terribly special. I've got two databases, Blog Shard 1, Blog Shard 2. They've got a very simple schema, blogs, posts, and users. No data in either one of them yet. And I've got a Blog Shard Manager database, which is just empty. So what I want to show you is my shard management application. So I mentioned earlier that the samples from Microsoft, is that better? Can you guys kind of see that? All right. The examples from Microsoft blend shard management and data management together, and I don't really like that. So that's part of the reason why I wanted to split this out. So in the shard management application here, don't ever do this, obviously. Yeah, exactly. What I'm going to do is I'm going to instantiate a new sharding instance, which is just happens to be a class that wraps the shard management object. I'm going to pass into it the shard server, the shard manager database name, and then the connection string to that database. This this process here internally, this is going to create a new shard map manager instance, which is going to connect to that database and basically apply to it a number of tables and store procedures that the Elastic Scale libraries need to be able to communicate. Then down here, the next step is I'm going to register each of my databases independently. So shard 1 and shard 2 are going to be registered. And I'm also going to register them with a given customer tenant identifier. So 14 and 29, 47 and 65, just some random customer numbers. And I'm going to register those with the database. So this is what enables the data-dependent routing to happen. And then when that's done, it's just going to tell me I'm basically done here. So make sure that this is the startup.
Is that sharding class part of the library or something?
It's just a wrapper. I'll bring that up. Yeah, it's just a wrapper with for that. So inside of here, I basically have a shard map manager instance and the shard map, and then basically the constructor. It's taking the connection string, and it's going to call this try get SQL shard map manager. So this will either create it or return a reference to that if it exists, and then set that instance to my local member variable here. And then it'll do the same thing with the shard map. So I'm providing a shard map name of, I think, one tug or something, just to be able to identify these things within the manager database. So to answer your question, you probably could shard multiple layers here within the same instance if you used a different shard map manager name. I've never tried that. That's a really interesting question. All right, so the next step, so let me just show you what that did, because it's really not all that impressive at first. If I refresh this, you see I've got all these underscore shard management options here, or tables, and there's some store procedures. I really wouldn't go mucking around with these too much. You can take a look at them, but a lot of it is just reference information. The other thing that these will do is it will put the same information, or a set of this information, into your application as well, into your database. So each database, each shard, is going to have its own reference copy of what shardlets are part of that, what customers are part of this database. And there's some repair utilities and things like that that kind of take advantage of these things from time to time if you need them to, if something gets out of whack. It's enough of a pain. We have our database under source control, and it's enough of a pain for us that we actually took the schema of these objects and put them under source control just so we could eliminate all the false positives of, hey, you need to drop these tables or add these tables because they didn't exist. It was just too much of a pain, so we just periodically, if we update the database, Elastic Database client tools, we just make sure that the schemas are identical when we use that. All right, so nothing super special about that and interesting, but now we've kind of set the stage for using data-dependent routing. So here, what we're going to do, it's very similar in structure. I'm going to instantiate a new instance of the sharding client. And here, I've basically just said, I just want to expose a shard map manager to my application. And then what I want to do is create new entries into the tables. And given a specific customer. So here I'm going to register data for first tenant happens to be 14 and 29. If this goes right, we will end up with records in these tables here. So let me run this. All right, so we need to create a new blog for tenant 1. Let's say, I don't know. And I don't know, Joe Zach's not here, but we'll pick on him and say Zach Stack. All right, so probably not super impressive, but basically what this did was it's a new blogging object, wrote that into the correct database table, queried that back, and it displayed it for us here. So let's take a look at, I don't know, maybe the database first. And so really advanced SQL here. We're going to connect to each one of these databases and select star from DBA blogs. See what happens here. Really? All right, so we see in 2 different databases the 2 different blogs that have been entered. So as we registered this, if we look at this a little bit more closely, we're passing in to the Elastic Scale, and this is actually more interesting to take a look at. All right, so we have this Elastic Scale context, which basically wraps a DB context, and it takes a generic here. It can be your int or whatever your sharding key is, basically, is what you're going to pass into it. It knows about our DB set, and there's some things here that allow you to, if you want to use Entity Framework code first to do some migrations, you could hook this up to do that. I copy this a lot from the Microsoft examples. This is the interesting thing. So in my public constructor, I can pass in a shard map, the sharding key, and then the shard manager connection string. And internally, it's going to call this private method to create a dynamic database, a DDR connection. And internally, it's going to basically get an instance of the map that contains that information. It's going to open up a connection, and basically the SQL connection gets returned and passed into our DB context. And at that point, that's what enables the Entity Framework code to be able to read the correct information from the correct database. Yep.
What authentication options are overall?
What's that?
What authentication options are available?
That's a good question. We have typically used the contained database user within Azure. I don't think there's any reason why you couldn't use a Active Directory managed instance principal, I guess what they're called. I've never done that, but we use that for connection. Like if we're going to connect to the database from a SQL Server, for example, we use the Azure Active Directory users. But from our main application, we basically just have a proxy user that all the connections are routed through. But I think there's probably no reason why you couldn't do the same thing here.
That Elastic Scale context, is that yours, or is that?
This is straight up ripped from the Microsoft samples. This Elastic Scale context.
From the sample?
Yeah, exactly. So, like I said, we don't use Entity Framework all that much. Where we are, we use a lot of ADO.NET and kind of Dynamics. Kind of have our own sort of mini ORM that we utilize. Okay, so that's dynamic data routing, and let's just take a look at multi-shard querying for a second too. So again, this code looks pretty similar. In our execute multi-shard query method that I wrote, basically I'm going to instantiate a multi-shard connection. And I'm passing in the shard map and the get shard. So this is basically a listing of all the shards that my shard manager knows about. And I'm passing a connection string in. This is going to return to me this multi-shard connection object. Now internally, if you go look at the source code for this, it's pretty impressive. Because what they're going to do is fan out and issue this same SQL command across all of the different databases that are in my shard set, await the results, and bring those back to me, which is pretty clever code. All I care about from an application developer standpoint is creating a command, select star from blogs, specifying the timeout, and basically executing that. So what I'm just doing here is a little bit of a dynamic. I'm taking my object, putting it to a dynamic or expando object, and then I'm just going to return that list of results and then spit it out on the console screen here. So again, since we're not using, or since Entity Framework doesn't have multi-shard query capabilities, you have to kind of roll your own solution for this a little bit.
It's almost like you have to have your shard manager and Entity Framework.
Yeah, exactly. I think there's some technical limitations of why they have. I know people have issued pull requests, and I think they've been rejected because there's some technical considerations that magic that yeah, exactly. I think if they could do it, they would do it pretty easily. So again, nothing super super impressive other than the fact that this one command queried multiple databases and returned me back my results, which is what I'd expect to see. I do have one more demo. Let me see about the time here. Yep.
You mentioned how it handles aggregation as far as like maybe you have to have them all, or maybe one's good enough, or somewhere in between.
Yeah, there's some properties you can set off of the multi-shard connection there that would.
Is that fairly robust, or is that?
My experience is it has been. I mean, where you would see a lot of, not a lot, where you might see some issues is the resiliency of your connections. So if there's some sort of transient, latency connecting to a cloud database, for example, you probably want to have some retry logic within your application that would enable an automatic retry, so it just doesn't fail and give up after the first failure. In practice, for us, we've been using this for quite a while. I really haven't seen very many issues. I mean, if we saw an issue, it would be related to a bigger data center type issue, I think. So from a resiliency standpoint, I think it's pretty robust. Yes, so we'll talk about that in a couple slides here, but that does exist. So you might, when I first started looking at multi-shard query, I was like, where would I ever use this in my application? And then it dawned on me how we could use that. So I'll give you a little bit of an example as I switch back over to the slides. We adopted a subdomain per customer approach. So when you come to our application, you put in your particular subdomain. We sniff that out. We do a multi-shard query that basically says, what's your identity provider, or your preferred identity provider given this subdomain? So we don't store usernames and passwords at all. We delegate that either to Azure Active Directory or to Google or some other third-party identity provider. We route all that through Identity Server that we manage separately. So basically what the request comes into us, we say, what's the subdomain? Where do we route this to? And we do issue a multi-shard query to get that information. And we do a little bit of cheating because we will cache that in a memory cache object as well. We take that incoming request, we route you out to Identity Server with some hints. That routes you in turn to your identity provider. It comes back in. At that point, we know you've authenticated. And now we just have to see whether you're authorized to actually use our application. So now we can say, all right, well, we know you're part of this customer. Let's go figure out what tenant you belong to. And we'll stick some claims basically into that identity principal object so that we then know for future requests that you're making as a user how to route you to the appropriate database. You could do something similar where if you said, and you see this a lot with say like Google or even Microsoft, if you go to like a site and you have to log in with your Microsoft credentials, right? Well, they've got a couple different forms of that. They've got Microsoft accounts and they've got organizational accounts and things like that. You log in, they kind of look you up, and I imagine they're doing something akin to a multi-shard query where they say, oh, you're an organizational account user, so we have to route your request here to log in, or oh, you're a Microsoft account. Or they might say, we have an identity for you in both, which one you want to sign in for, et cetera. If you've been a long-time MSDN subscriber, it's an awful experience. Don't get me started. But it is what it is. But so that's kind of where I don't think you'll probably, in practice, implement a ton of multi-shard queries across your application. Obviously, it depends on your app that you're building, but for us, that's one way that we can utilize it. All right, so a couple more slides here. Uh-oh. I do want to touch on this a little bit, multi-tenancy and row-level security. So dynamic data requests don't protect you from tenant leakage. And by that I mean is if you have multiple customers in a given database and you say, hey, I want to query everything out of database 2, you can do that, and it will return all the results from database 2, regardless of what customer you're assigned to. If you're using the single database or single tenant approach, you don't have that issue, right? But if a multi-tenant database approach, you certainly have that issue. It's a really big concern for me and probably for a lot of you if you adopt this. A couple years ago, I did a lightning talk on Rowlevel Security, which is outside of the scope of this talk here. But Rowlevel Security is a feature of SQL Server that enables you to create a policy that describes, basically as an added protection for you. So it inserts a where clause, essentially, into every request. And it says, oh, I know you're coming in for customer 5, even though your developer was lazy and didn't put a where customer 5 or customer equals customer 5 where clause, it will inject that for you automatically. And so it will safeguard your data from this sort of tenant leakage. And you can customize these security policies however you see fit. And they're not specific to Azure SQL Database. You can do them in SQL Server on-prem as well. If you're interested in that, come grab me afterwards. I'll be happy to talk to you about that a little bit more.
It's got to be injecting that on every table in the query too, right?
Yeah, so that's why in that scenario you want to have that sharding key a part of every single database table that you keep customer related data to. Exactly. But you're going to do that anyways if you have a multi-tenant application in most parts. So it's just injecting that request there. It's a little bit of extra overhead. But for me, it's worth it because I don't want to wake up in the middle of the night because we forgot a where clause in some statement someplace. Split merge tools. I think you asked about moving data. So you can certainly move data across different shards. So if you have a problem customer who maybe is beating on your database a little bit too much, you can push them over into their own database. The split merge tool is what you're going to use for that. It's runs as a service, specifically a cloud service. So you get a web and a worker role. You're charged for this, so you're charged basically for the consumption. So you're going to spin one of these things up, and you can scale it up in the Azure database or in the Azure portal to the size that you need. And you want to make sure that it's big enough and your instance of the SQL Server database is big enough to handle this. What it's going to do is basically in that shard, it's going to kill all of your data-dependent routing requests initially. It's going to kill them all, and then it's going to essentially lock the shardlets that are involved in the move. So any request that comes in for customer 5, well, if customer 5 is moving to another database, those are going to be denied. So you're basically taking your customer offline for the period of this batching process while you move that data to a different database. Yep.
So maybe this is a dumb question. What about the IDs? You say you have customer 3 over here, customer 3 over here, and you're merging all this data. Now you've got an ID collision. Is that because is it a composite key with the?
Yeah. So what I would say. Yeah, so that sharding key that you choose, customer ID 3, hopefully there's only one customer ID 3. Whatever database that customer resides in, that's there. And every table really becomes a compound primary key of customer ID and then order ID, for example. So every join that you make is probably going to be customer ID on customer ID, order ID to order ID, or whatever the case is. When you move that, so the idea is that if that customer ID is unique, as you move that data to a different database or kind of merge that back in, you're still going to have unique records because you're not going to have a collision because the compound primary key in the table kind of manages that. So you might have order 10 across 10 different customers, but there's only one order 10 for customer 3, if that makes sense.
But what about just customer 3, and you want to move it over?
You shouldn't have 2 customer 3s. You have 1 customer 3, basically.
Per tenant,
Yeah, the tenant is the customer in that case.
Stop it if they're independent. If you have 1 customer per whatever, you go to
The data dependent routing. So when you're onboarding your customer, when you're creating those ranges, when you set them up, theoretically you're preventing customer 3 from existing more than once, essentially.
Scenario, he's talking about you assign the customer ID.
Yeah.
It's your, if you have it, then you probably can't use this approach.
Say that one more time.
If you've got identities in 2 different databases, there's nothing to stop 3 from existing in 2 different places independently of each other. They're 2 different customers, but then if you end up merging them, they are going to collide. There's nothing you can do about it.
Are you talking about an existing database?
You have a customer 3 that you're now merging into.
Okay.
You already had a customer 3.
Yeah. In that case, you probably have to do something with that customer, that identifier, to change it or tweak it somehow. That might be an interesting scenario for using something like a GUID, right, as a key instead. Yeah, exactly.
For using what?
What's that?
For using what?
If you were to use a GUID, for example, you might eliminate that possibility, right?
So
In terms of what? Like, does it?
So, like, do I have any hooks to look into the shards and see that they are not behaving the way I want to, or exceeding some kind of metric?
Not directly with the split merge tool. I think you could get some better.
Like on Azure, like you have a query performance insights that you can.
Yeah, exactly. I think you'd be monitoring. This doesn't replace the monitoring aspect of your application. So you'd probably want to be looking at what is the usage patterns. Do I see a spike in the traffic? Who's?
If it meets a certain condition, I want to run the split merge.
Oh, I don't. I bet you could probably do something like that. I've never thought about it that way. But yeah.
Just curious.
Yeah.
Does the split merge tool support any other deployment model on Azure than a cloud service, given an application of cloud service?
Not yet. Have they announced that it's deprecated completely? Or I know it's not getting any love. I know, yeah, at some point, but I would imagine that at some point they will have to move that. 2021 for cloud services? Okay. Yeah, I guess they're going to have to update that project.
So is the practical application of this something where I've been doing a, multi-tenant application, I got all my, 25 customers, and one customer calls and says, I really need to be in a different database all my own.
Yep.
You use this tool, pushes all his data in his
Right.
own, and now he's in his own.
Yep.
You solve that problem.
Exactly.
That's the value of
Yep.
this.
Or let's say you have some seasonal aspect of ebbs and flows of your traffic, for example, and you want to say, all right, I need to scale out to multiple databases and push these 5 customers because I know at the end of the year they're really going to be beating on the system. I want to have them in their own databases potentially. You can split them out, but then maybe the quarter ends and they're done. You can split or merge them all back together into the same database and have some cost savings there. Nothing's for free. You're obviously going to have some downtime as you're moving this data around. It depends on how much data there is and how long it takes, et cetera. But
And when you moved them up in these other databases, now you got the cost of these.
the cost of that, exactly.
But it knows about all the foreign key stuff, and you don't have to deal with that?
That's why when you're registering your shards initially, one of the options that you can do is basically say, here's info about all of my schema, and you basically say, here's all of my sharded tables, and here's the key field across them. Here's the sharding key as this field, and all the reference tables. So this split merge, what it's going to do is ignore all of your reference tables. It's just going to focus on moving customer 5 from database 1 to database 2, for example, and it's just going to move its individual data, that shardlet data. It's up to you to make sure that your reference information is kept up to date across all those, but it should be. It's zip codes and things like that.
I'm talking about the hierarchy of tables that
Yeah.
you own, not the
Yeah,
reference.
yeah. It's gonna go through and it's gonna figure that out. Yeah, that's its purpose.
Will that keep it synced as you update your schema over time?
You do need to replace it, so you have to have a process to make sure that you go through and do that. It's a great question because it's easy to forget that step. But you're gonna have problems if you go to split data out and it just doesn't include all those tables. So you want to make sure they have a double check there when you go to do that. So we kind of talked a little bit about when you might use this, shrinking capacity, managing hotspots of different tenants, et cetera, moving them around. So explosive growth would be a great problem to have, right, for all of us. All right, Elastic Database jobs. I'm going to take too much more time here. Similar to SQL Server agent jobs, but for Azure SQL Database. You can target any number of Azure SQL databases that are available to you in your cloud, and that are, as long as they're in the same area as the job agent. And they have all kinds of different support for this. You can use PowerShell, the Azure portal, you can run T-SQL jobs, et cetera, Azure Resource Manager to configure this stuff. Essentially what you do, if you want to use this, is you create another database. It becomes your jobs database, and then you hook up an agent to it. And then within this process, you go ahead and essentially define what are all the databases that this job relates to. And then you can define the job steps. So you might say, hey, go ahead and reindex all the databases or update the statistics. Or, for example, let's say you have to deploy a new schema out. You might have your idempotent change script. And you basically say, this is a job. Run this across all of my databases that are in my shard set, et cetera. You might want to collect performance data as well. Really important, whatever you're doing here, you want to make sure that your T-SQL scripts that you're executing are idempotent. So it basically means that if you're going to create a new table, you first check to make sure that the table doesn't exist before you try to create it, for example. So that way you're guaranteed to have the same essentially outcome and results when you're done with your script.
So did I understand you to say that I can basically run my update script? We use what is it called now? DBA.
Yeah.
We use DBA.
Okay.
And basically, we just run that against the connection string, and it, updates the schema, number 92 or whatever.
Right.
we're up to. We just run that the same way, and it will take care of updating the schema
Yeah.
of every single shard
Yeah.
database.
Yeah.
Awesome.
Yeah. So it's meant to automate that tedious process. If you have a lot of databases and you want to make sure that they all get updated, that's probably the way to go, is to automate that process.
And when it does the schema changes, does the Shard Manager update itself also?
My understanding is that it won't update itself in terms of understanding all of the new tables that you've added. I think that's the other step that you probably have to run at some point to say, hey, I need to update my schema collection information to say I need to add these 5 new tables into the schema, so that if you do have to split or merge, that it knows about those tables. So there's a little bit of a disconnect there, but if I figure out a better way of doing it, I'll update my slide deck. A couple more slides here. So Elastic Query is still in preview, but this is what provides you the ability to issue a T-SQL statement across any number of Azure SQL databases. This doesn't have to be sharded databases. This could be databases that are related. So maybe you have an HR and a CRM system, and those two need to query each other periodically. You can set this up. It's very similar to if you're on-prem and you're going to say joining databases together or using link servers. You can't do link servers in Azure SQL Database. This is the way that you do it, is through Azure SQL Query. And there's some magic that this happens. Basically, well, the reason why you use it probably is in most cases either you have a need for your application to be able to do this, or you want to do some sort of aggregation, Excel, Power BI, et cetera. Oops. So a couple of the examples that Microsoft provides is in the upper right-hand quadrant, they have a reference database. So that's reference data that is shared across all these different databases. They might issue a Elastic query to query out that information. And essentially what you're doing is you're registering these tables that exist in a different database as though they're local tables to the database that you're in, that you're issuing the query from. And it's a little bit of magic, but you have to create a master key and a database scope credential, et cetera. And then once that's there, when you say select star from ref.zip codes, it goes out to that database and says, oh yeah, here's all the zip codes if you want to share that across that.
So it is like a link server.
Yeah, it's essentially a link server just in the cloud. The Elastic Scale, for my sake, the Elastic Scale multi-shard queries are kind of interesting because you're going to, again, do the same thing. You're going to register this special table or series of tables that really exist in each one of these databases. There's essentially a clone. It doesn't have any data, but it knows how to go out and query those different databases for that information. We don't use this in practice. We might have at some point have a need for it. Most of our multi-shard querying capabilities happen within our application. But as this matures and becomes more robust, I can see us taking advantage of it. Yep.
What's the performance impact of querying across that many databases?
I don't know. That's a great question. I haven't coded against this in anger. I can't imagine that it's any worse off than issuing the multi-shard query from your client, your data layer, data application layer. But yeah, it's a good. I think it probably comes down to what kind of data are you querying, how big is the result set going to be, et cetera.
I think that if you use the shard key, it would be more efficient as opposed to fanning out all these.
Yeah, I would guess that's probably the case too. This really seems like, if you wanted to aggregate data across multiple, customers and do some sort of an analytics, you might set something up to run overnight to query all this stuff when maybe your usage is low and you're not interfering with your customers hitting the system, et cetera. So that's about it. Brief recap. My opinion, Azure SQL Database and database tools themselves are pretty flexible, but they can be a little bit complicated to get started with. I would encourage you, if you're going to use this, start with some small proof of concepts like you would any other technology. And make sure you test your hypotheses around your usage scenarios. Is it okay to have single tenant models where every customer gets their own database? How's management going to feel about that? What about, if you opt for the multi-tenant model, are customers going to complain about that? Are there any sort of legal requirements that you have to be aware of If you're doing greenfield development, it might make sense to design your database to be multi-tenant, even if you don't take advantage of that. It might give you some room to sort of grow and make those decisions down the road. And then, I don't know, my personal opinion is that, keeping up with Microsoft technologies, especially Azure, is like drinking from a fire hose. It's impossible to keep up with it. Do your best, because this stuff does change, particularly around the Azure SQL Database offerings. They're always changing things, it seems like. So definitely try to stay abreast of that, because some problem you have today might not be a problem 3 months from now. Any questions?
Do you know of any GitHub repos or anything that might have sample code?
The Elastic Scale, so I mentioned, I think,